Hello everyone, we are from Group 2 Session 2 and we will be presenting about smart sorting bins. This is our team presentation and I'm Kelvin Chong and I'm the mastermind of the team, and we have the creator of the team, Twu Le Sen, and then the designer of the team, Hawary, and the industry spy of the team, Arash. Smart sorting bin is the concept of smart waste management system with the implementations of IoT, the Internet of Things, which enable it to communicate directly with the smart sensors and software. The wide usage of smart sorting bins create an IoT ecosystem where the data is collected to form a database for future analysis and forecasting. Hence, the objective of the smart sorting bins is to integrate IoT technology with Malaysia's current waste management system and to design a system that could perform automated sorting features to ease recycling. Also to develop a system that could bridge the recycling agents of centers with the users to buy back those recyclable items to increase the recycling rate of the country. In Malaysia, we achieved a new high of 28% recycling rate in 2019, which equivalent to 87,049 tons of waste being recycled. However, Malaysia landfill diversion rate is still high at 88%. Hence, research show that due to the limited sorting facility, there's still about 30% of potential recyclable items being disposed of directly to landfill. According to the data from JPSPNs, the household waste comprise of mainly plastic, papers, diapers, garden waste, glass, and metals. In the recycling market, these major items are mostly highly recyclable and attain a certain buyback values if it is sold to the recycling market. Now we look into the need. For recycling centers, they often have hard time to know where to find the recyclable wastes to buy back, as people are either too lazy or too busy to sort them out individually to send for recycling. Also, in most developed cities, urbanization is taking place, which means that a large number of people will concentrate at a small city. This phenomenon arises problems like traffic congestion, overflowing dustbins, and hygienic problems. Meanwhile, in rural areas where garbage collectors is still mostly inaccessible, open burnings and open dumpings become their only choice to dispose of the wastes. To effectively tackle these problems, smart sorting bins is designed, and we look into the approach of the smart sorting bins. Route optimizations helps to effectively plan the trip to collect those only a most full dustbin by skipping those unnecessary trips. Meanwhile, real-time fuel level sensing monitor the fuel level of the dustbin so that it won't overflow and create hygienic problems. Forecasting and predictions, which can predict and forecast the fuel level in each dustbin and plan the trip in advance and become fully automated in the future. Auto notifications connect the recycling agents and the garbage collector to rural area and also the urban area by having auto notifications with locations attached. It sends notifications to both garbage collector and recycling agents simultaneously to collect the full compartments. Smart sorting bins enables the smart sorting features that help to promote segregation and while keeping the recycling rate at the minimum effort. This approach are specifically designed to solve the before-mentioned problems. Next, I will pass to the next presenter, Arash, to talk about the benefits.
Thank you, Kelvin. For the benefit part, the product is called Smart Sorting Bin for reasons. This product has several benefits that are very useful for its consumer. First, sustainability. The selection of the component is made carefully with full consideration of its sustainability and durability. As all parts are modular, the components are all easily replaceable. Second, income generation. The system allows users to generate income by recycling and saving time to send the recycling item to recycling center. It is now done at the user doorstep. Third, time saving. It can automatically sort the trash that is put inside the bin. It can detect if the trash is metal, glass, plastic, or wet waste. Metal, glass, and plastic are the categories with the higher recycling value and are the most common type of waste. Fourth, environmental friendliness. The smart sorting bin requires no other external power source. The solar panel is built directly into the cover of the dustbin. Hence, the solar power is sufficient to power up the system for a long period as it requires very little power. A single full charge is expected to take 1 hour under normal sunlight condition and is estimated to last 1 month under normal usage. Lastly, user friendliness. The smart sorting bin is designed to be modular with an easy installation procedure. This could save transportation costs and storage. The user can modify the existing dustbin to become a smart sorting bin. 4 wheels were installed to provide portability for the dustbin. The smart sorting bin designed for the waste to be taken out easily, as the trash bin has a door on both sides of the smart sorting. With the locking function, the dustbin will stay in place. I will pass the presentation to the next presenter, Hawary. Thank you.
So now I will talk about the competitions. We have two types of our competitors. The first one is available waste management system, and the second one is available commercial product. For available waste management system, we found 3 waste management which are Enable, Big Belly, and Auto. All these 3 waste management systems provide the solution for waste problem for their country. Next, for available commercial product, we found 3 smart sorting bin which are Trashbot, Flakes, and Bin E, while the other one is manual sorting bin which is Sortera IKEA. This one is comparison of available product with our product. We can see here the Sortera cannot auto sorting the type of waste and also the Trashbot. For field level sensing, it's only available in Bin E, Flakes, and our smart sorting bin. For AI or machine learning, it's only for Bin E, Trashbot, and Flakes. Mobile application for Bin E and our smart sorting bin. Modular is our smart sorting bin. Automatic alert notification for our smart sorting bin. Solar panel is only for our smart sorting bin. And provide hotspot feature is for Bin E and Trashbot. And compression is for Bin E and Flakes. It's software simulation.
So this is the flowchart of the project. It started from inputting the wastes. Only when an object is sensed, it will proceed to activate the sensors. If not, it will return back to its initial state. Then following the sequence, it will activate the waste sensor first. If it's yes, then it will move to the wet waste bin. If it's not, it will activate the metal sensor to sense the metal. If it's a yes, then it will go to the metal bin. If not, it will proceed to activate the capacitive sensor that is set to detect glass. And if glass is detected, it will move to the glass bin. If it's not glass, then it will activate the capacitive sensor that is set to detect plastic. If it's a yes, then it will move to the plastic bin. If it's not, it's very likely that this item is not supported by the project at this stage, like wood, fabric, or paper, and sent to wet waste. All the bins are monitored by the ultrasonic sensor to check its fuel level from time to time. When it's over 80%, it will trigger the SMS to alert garbage collector or recycling agents to collect.
This is a simulations done using Proteus software. Before we look into the simulations result, we first set the fuel level conditions inside each bins. Ultrasonic sensor is used to monitor the fuel level of the dustbin. Hence, when the value is set at 0, which means that there's 0% space left. When we set the value to 22%, it means that there are still 22% space left, and it's only 78% full and will only triggers the SMS notifications at 80%. Object sensing is to make sure that the system will not be activated by any other factors than the waste issues. Sensor like soil moisture sensor is very sensitive towards the change in humidity. So when it's turned off, it will output a message saying that there's no object detected and please try again. In the conditions where the object sensing is turned on but none of the sensor is turned on, or more than one sensor are turned on, it will output a message saying that this object is unidentifiable.
And set to wet waste.
When the metal sensing is turned on, it will output a message saying that the metal is detected and the fuel level is critical, because we have set the fuel level conditions inside it to be 0%. That means it's full. And what it does is this servo motor will turn to its respective bin, and this servo motor will turn 90 degrees so that it lets the metals to slide directly through the pipe to its final destination. When the glass sensing is turned on, and we can see that it will output the result saying that the glass is detected and the fuel level is normal, because we set the fuel level conditions in glass compartments to be 22% space left. The same goes with when plastic sensor is turned on and the others is turned off. It will output a message saying that the plastic is detected and the fuel level is normal, because we have set the plastic fuel level conditions to be 23% space.
And this one is our prototype demonstration.
Hello everyone, so now I'll show our project prototype, the smart sorting bin. So totally look at a square shape. In the behind of the smart sorting bin, we got LCD here is to show the full fuel level of the bin. And the top of the smart sorting bin should have a solar panel to charge to let our project function. And here we got a hole to throw the waste inside, and the sensor are all there to detect the recycle waste we throw into. And then in front here, we use a magnetic door lock to lock our door. And this is the rotating part to let our waste to the through compartment. And inside we got 4 compartments to each recycle waste like paper, plastic, metal, glass, and waste. And here is the circuit. And the sensor I put here is easy to take out. It is already repairability. And the compartment here is a removable compartment, so we are easily also to collect the recycled waste that we threw out. Okay, so let me see at the bottom of the smart sorting bin, we got a 4 roller at there. So this is extreme probability to move the smart sorting bin. Okay, so that's all for the prototype. Okay, so now let me try to demo the sensor part. So here we got for waste, metal, and glass, and the plastic bin here. And now we use the tomato to detect which the waste is. So we put into the input the hole here, and the soil moisture sensor and the IR sensor will function, and the tomato will go to the wet waste bin that we see. Okay. So the next we use the metal ball to try. When we put into the hole, the inductive sensor and the IR sensor will function, and the pipe will go to the through compartment. The metal ball will go into the metal compartment. And next one we use the plastic bottle. So we put into. And the capacity sensor will off, and the IR sensor will detect, and the plastic will go to the waste bin like based on our flow chart. Okay. So the next one we use the glass bottle. This is a glass bottle. We put inside, the IR sensor and the capacity sensor will function, and the pipe will go to the through compartment, and the glass will go into the glass compartment. And then the last one is the wood. This is the unsupported thing in our project. So when we put the IR sensor only will function, and the would also go to the waste bin that we see. So that's all the demo part. Thank you. Okay, so now let me demo the other part. So you can see here the full level of our bin, which are 30 cm something. So let me put a bottle under the ultrasonic sensor. This is in the metal bin. So we can see here the LCD will show the metal level. M level is only 5 cm. So means the metal bin is already full. So we will get a message that alert someone to collect the waste. Like you can see here, please collect waste, MJIIT.
The fuel level can also be monitored by the user using the Blink app.
So that's all for our project demo part.
Next slide, I will pass to lesson.
So this is the result table of our project. So we are already used a lot of material to calculate the accuracy of the sensor, but here we just only use 3 samples to show the result. Okay, so from this table we can see that the first one we are used the inductive sensor to detect the metal, and we can see here they are very accurate. The sample we use is a key, a spoon, and a screwdriver, and all are detected as a metal. So the accuracy, like can say 100%. So the next one is the glass. We use capacity sensor to detect the glass. So here we got the chili sauce and 2 kind of cup. But here we can see there are only 1 cup is detected as the glass, and another one doesn't. So the capacity sensor are only on for the first 2 sample, and the last sample is off. So the last sample will detect as the wet waste. Okay, so the third one we are also using the capacity sensor also, but this time we are used to detect the plastic. Unfortunately, after our testing, the capacity sensor cannot to detect the plastic. So the capacity sensor is always off. Then the plastic bag, the plastic bottle, and a glove are differentiated as wet waste based on our flow chart. Okay. So the last one, we are using the soil moisture sensor to detect wet waste, and this is same like metal. This is very accurate. So like we can see, here we got lemon, tomato, and wet cloth. Okay, so accuracy also same, like 100%. Is very accurate. Okay, and then we can see about our graph. So this is our graph. We can see the metal, glass, and plastic, and the wet waste. Okay, so the metal and the wet waste is 100% to detect, and the glass is around 67%, and the last one that is unfortunately is 0%. Okay, so after our testing, we will find some of the potential error and some of the solution to solve the problem. So the potential errors identification is the inconsistency of capacity sensor to detect materials of the same kind, and unable of capacity sensor detecting plastic, and the last one is inaccurate detection of object in some complicated condition. So the solution to solve the potential error is to adjust the higher sensitivity of the capacity sensor to detect more glass, and replace the plastic bin to the unsupported bin. And the last one is the sequence of the coding to make sure that the complicated condition is also can detect accurately for the recycle. Let us reuse the past, recycle the present, and save the future to start recycling. And then we start recycling today. So thank you for watching. That's all for us. See you again. Thank you very much.